Okay, so I'm gonna record another session of programming chess programming, improvised, whatever I called it. AI Professor Improvises Chess Programming. I think that's what I named the series. I'm live on Twitch. I don't know if there's anyone watching, but that's fine. If you are watching, feel free to ask questions in the chat. And let's see. So I will begin. So I have some minor updates since the last session. It's not showing one of the windows I want to show, but it's I was able to hook up what I was working on to Lichess. So lichess.org, one of my favorite chess websites. It's able to connect bots to APIs, through an API to allow computer program to play chess, and it's all fair, right? You do it with an account that is registered as a bot, so it's not you're not cheating. We're specifically saying we're just programming a bot to compete against, I guess, against humans or other bots, but where the human always knows they're playing a computer if they do that. And so I did this through this the Lichess API. Or actually, this is not the Lichess API. This is a special Python bridge to the Lichess API, and it was really easy. Now I didn't really take advantage of most of the things that you're able to do. So all I did was basically if you look at this repository, the instructions by the developer just say, the basic thing you can do is just implement a search function, and the search function, what it does is it takes a current board position, which is just like what we did before, and searches over all the actually, I shouldn't even say searches anything. It returns a move object. That is the move that is the chosen, move to take. And that's the simplest thing. You could just do that, and that's all I've done. I basically ported over what we did in the last video into that framework, and that's what's on the right here. And you can see I implement. So this score engine is what we had named. What we had created in the last video, and now I'm extending, or now I'm having a subclass, something called the minimal engine, which if we follow, I'm using PyCharm here as my IDE. So minimal engine is this thing from the strategies.py, which comes from this repository, and it implements everything that you need to do to create an engine, but it doesn't do, right? So it doesn't implement the actual search function. It has some stuff like search with ponder, which maybe we'll talk about. But basically, ponder means the engine will think when it's not the engine's turn, when it's the other player's turn. And for now, we're not implementing that. So for now, we're just going to think only when it's our turn. And I'm only going to implement something relatively simple. But I guess the goal today. So first off, let me just quickly show you this thing running. This is the custom engine. We're currently using what's our score? Score function is self.score function. Oh, I set it to improve score. So the score, this engine here just searches over moves. I'm gonna quickly change this just because I don't like. This is still not my favorite way to do it, but. Okay, so here's what this function does. This search function is a very generic search function. What it does is it has a score function that's stored in the class. It's a class member. It's a function. So this is like slightly functional programming. It's perhaps not fancy enough to really call it super functional, but anyway, we're storing a function object, and then we call it on the board, and the way I call it is I give it whose turn it is. That we might need to adjust, but anyway, so it gets a score, and then it just, this loop here searches over all the possible legal moves and returns the legal move with the best score. So pretty generic, and probably won't be, we won't be changing this much. What we will change is what the score function is, and right now it's set to improved score, which was this thing we hacked together last time. So first it starts with a material count, then if it's a checkmate, it puts a really large number. It's that number hopefully will be robust enough to always be the largest possible number that we want. And then we also checked for space, which I'm not sure how much this actually affected things, but it helped a little bit. And then I also tried to remove hanging pieces. So some of this stuff I want to get rid of right away after we first demo the API, because I want to build a look-ahead engine that is as simple as possible, right? So it's using a score function that's not too over-engineered. So let's just try running it first. The way you run this is you run a separate script called Lichess bot, which I think is configured to, yeah. So I configured PyCharm to run that. So now it's connected to lichess.org and awaiting challenges, and then you can look at on this browser over here on the left. It's hard to read. Sorry, I can zoom it in. So this is the page of my Bert bot. This is my bot. I'm Bert. I don't know if I introduced myself. I'm Bert. Hi. Yeah. So here's my bot. You can follow it if you want. If you're on Lichess, and I'm going to challenge it to a game. So let's challenge it to a quick game. I don't think I accept I think I configured it not to accept rated games for now, because like right now while we're building it, at some point maybe I'll just set it to accept rating. Someone just challenged me. Okay. Kyle has challenged me. I know Kyle. Okay, so so all right, so let's do I'll just do a random side. Let's see if it works. So I think the bot is playing 2 games. Is it not accepting my challenge? Is it only accepting 1 challenge at a time? I'm not sure why it's stuck. Process used, total used. Okay. It was working before. By before I mean a few days ago. So I might have done something. To break things. Let's see. August. Oh, okay. Wait. It worked. Okay. Oh yeah. So there, BertBot made an okay opening move, and we can just play a couple stuff. Okay. That Kyle, I don't know if you probably didn't cause any problems that you should. I mean, any problems is my fault or something wrong with the code. Because I don't think it's not playing you, is it? This isn't even me. No, this is me. I'm playing the bot now. Anyway, so yeah, so this bot is not good. At some point I'm just gonna get at some point I should be able to capture the queen, because I don't think it's smart enough to understand, that. I'm just gonna develop. Let's see if I keep threatening the queen. Yeah, see it. Okay. Yeah, so the bot's not good yet. Not being able to look ahead, not being able to think that, oh, on the next turn, this human will be able to take my queen. It just can't do that, right? It's not. I didn't make it smart enough to do that. But that's the goal. The goal today. The goal today is to try to make it look ahead. And you can think of what I did last video, as basically trying to fake look ahead, right? This idea of looking at hanging pieces, like removing hanging pieces, that's basically this idea of looking ahead, right? Of trying to see what pieces are available for the opponent to take on the next turn. I can leave this open, and then as we change the engine, it will change its strategy. Although now it's down to queen. Here, I was thinking I could try to hang my queen. Here, I'll just see if it takes my queen. Nice job. Okay. All right, so I'll leave it here, and then as we improve the engine, maybe we'll see it do better, or it'll just crash. We'll see. Okay. Let's see. So let's do this. So my plan now is to change the score function so that it's now going to actually look ahead and say, okay, well, what's the score if I look, if my opponent plays the best move after I play my move. So how do we do this? So the simplest way to do this is with a recursion, right? So this is a recursive, sorry, I shouldn't say simplest. The kind of the most easiest to, the shortest version is with a recursion, and that'll cause some issues, but it's probably the best way to do it first. So why don't we change improved score to, let's call it minimax score, which I haven't built yet, but now let's build minimax score. So the score functions I defined take in what? They take in a board and then the turn. So let's say we do the turn. Okay, so this is where programming live becomes exciting or embarrassing. Okay, so we can start with the base case. So in the base case, actually, you know what I'm going to do? I'm going to give it a depth. So let's say let's give it some parameters. So we're going to say max depth. So some of you, if you've looked at chess engines, you might recognize this idea of a depth. A depth is how many moves ahead it should look. So we're going to set by default the max depth is 3. I'm going to pick that number randomly. Okay, and then actually I'll put that just for consistency, or not consistency, convenience. I'm going to say current depth. Let's say current depth is equal to 0 by default. And so now the idea is when you call minimax score, it's going to default to the idea that the current depth is 0 and then the max depth is 3. And so then the base case is going to be, you know what, I'm going to do a little hacking. So I'm going to move this is checkmate to the material count. So the idea there is that I'm going to count being a checkmate as, oh, you know what, this is tricky. That's the right way to do this. Material difference, turn, okay, maybe, yeah, we'll have to think about this. This is a little, but for now, this is technically correct. So, score, material difference. All right, so I just did a little bit of hacking. So basically what I did here was I want the material count to just attribute a huge amount of material advantage if you've checkmated the opponent king. So now what I want is the material count to be just the basic score metric that we care about. That's what we care about, but the point is that we're going to look ahead multiple moves to determine what the material count will be for every possible move. And yeah, and then like this says, if you are able to checkmate the opponent, then you get a huge material advantage. It's not really material, but let's just say that you automatically look ahead one more time and you get to capture the king, right? Something like that. Okay. So now let's say this is the base case for the recursion. So if let's say current depth equals max depth, then we're going to return material count and I'm going to give it the new board, but I think I have to be a little careful here. I think I have to also consider if new board dot is checkmate, I think. So the two base cases, right? The end of the game, shoot. Checkmate's not the only way to end the game. Okay, let me think. I think we have to go to the API, which I don't have open. So let me open it. Python chess. So there's a function in here. Game end, I think. Game end detection. Let's see. That's not a link. Game won't find me. Okay, game end. Let's see. Is variant end? That's probably that's probably the most general way to do this. So is variant end is to capture if the game is over for other variants, not just chess, not just standard chess. But I don't want to deal with variants, so I'm going to look for the specific. Is stalemate, insufficient material. Those are all different types of ends. Maybe I will have to use is variant end. I don't love that, but it's okay. Yeah. I really thought I did this in my other code. One minor thing is I'm trying to keep this browser in the screen sharing size, which is very small, so I'm having trouble reading everything. Outcome, termination. I feel like it's got to have something to do with this. Well, I should just follow one of the principles I was going with before, which is just make it work and then clean it up later. So, okay, is variant end is probably what's going to work. So let's look at how you call that. So it's a Boolean, it checks if the game is over. All right, let's just do it. Is variant end. Okay. So I guess as a sanity check, again, just to make sure everything's working. Okay, so if it's not working, then if it's not a base case, we're going to do recursively reason about best move. Okay, and there's a little bit of there's going to be some repeating logic here because this logic is very similar. So I wonder if there's going to be a better way for me to implement this, to sort of copy this code into a separate helper function. But okay, for now, what I want to do is test if all this works. So I'll just set the maximum depth to 0, and I'll do that by calling it here. Okay, this is where's the better place to hard code this? I don't love hard coding stuff like this, but let's do that. So this should always be the base case, so it should just return material count. And so if I run this, I think I can. If I reset it, then I think it takes over the control of the bot. So now this should run without crashing. Let's see. And what's a way to test this? I will hang a piece and see if my bot takes it. Right. So that should, if it's basing it on material count, it should do that. Is it online? Waiting for opponent. Let me reload. I wonder why there's this delay. I wonder if it doesn't pick up a game that's in progress. That would be strange, but possible. Okay, well, if that's the case, then let's make a new game. So I'll just forfeit. How do I even do that? Forfeit and rematch. Okay, so now it accepted a challenge from my account, my personal account. Where is that game? I thought I accepted a challenge. Okay, I don't know why I didn't link to it right away. All right, so I'm playing as white, so I think what I'll do is, again, try to hang my pieces as fast as possible. Whoops, excuse me. Wait, what's a fast way to hang pieces? What happened? Oh, it reborted my game because I didn't start fast enough. Okay, let me try that again. Oh, now BirdBot is white, so let's see if... Pretty picky. Oh, shoot, this is... okay. Let me see if I can... Nope, that's an analysis board. Yeah, sorry about this. Let me just try to find these other bots that I follow. Okay, so here we go. So now is BirdBot correctly online? Let's see if we can accept a challenge to a game. Okay. Okay, let me try it again. So I'll just try to quickly. Oh, it's not working. All right. So is it crashing? Is it thinking forever? Did I mess something up? I don't think it's actually making a move. I think this would be outputting. This console would be outputting something if it were making a move. That's annoying. All right, what can I do to test this? Process queue, total queue. I'm gonna abort this game and just rematch and see what happens. It's really slow to accept anything. Let me try killing it and start it over. Okay, it's connected. And well, this is probably not very exciting. Sorry for technical. Well, this whole thing is about technical difficulties. We're just going to be working with technical difficulties until all of a sudden they're all gone and we have a working bot. But it would be nice for it to not be this type of technical difficulty. So it says it's awaiting challenges, and if I click on BirdBot, it's showing that BirdBot is online. So let's try again. Okay, now accept it. Okay, let's see if it actually makes a move this time. I wonder if this is a bug that I've introduced here, or if it's because it was playing before, right? So let's see. Is there anything that I've changed here? This float inf. I don't know. I doubt that would cause the problem, but could it have? I'm calling the score functions, and now the score function is minimax score, which is this thing. Oh, it's not returning anything. Oh, wait, no, it is, but maybe this is not. If this is not curve depth equals max depth, right now they're set to 0. So how could it not return material count new board? Oh, this, and I didn't pass in turn, so this should be crashing, but it's not showing that. Interesting. Okay, so that's something we should be aware of, is that if there's a bug, I'm not getting error messages. I think it's the way that the what do you call it? The API, or this software bridge to the API works. Okay. So now I will just abort this game and try again, just in case that's the issue. No, this is a different issue. Is that recursive function guaranteed to return? Yeah, I mean, that's what I was wondering before. It's not guaranteed, but with these current values, it should, right? Curve depth is 0, max depth is 0. Oh, I did and. Yeah, good question. That would probably be a cause for something to go wrong. So it's possible that was causing the problem. Let's see. This time we got an actual crash. Okay, let me just restart it. Nope, stop. I think there's some asynchronous stuff going on that's messing things up as well. Okay, Okay, and do I have a bunch of games open now? I have a game open. Okay, yeah, BirdBot made a move. Okay, so let's just see if, you know, here's a free queen. Come get, okay, free queen. Okay, nice. All right, well, so now it's working. That's really annoying that we can't see these error messages, but yes. So so this wasn't returning anything, or rather, the way it was set up, it was returning none, like a null object. So that's not good. But now it should work. So now this we don't believe is actually working. So I'm just gonna. What's the best way to handle this? Let's make this bot dumb and not know what a stalemate is. So if it stalemates, I'm okay with that. So let's just say it's going to wait. Oh, but then I won't be able to look ahead. Well, let's see what happens. I think I'm gonna look at the code for this. I feel like it should be. So is variant n checks if the game is over due to a special variant. Maybe it. There must be a way. There must be a game end here. Normal game end. Is checkmate insertion material. So what is this? This is outcome. So this is the outcome. Returns outcome if the game is ended, otherwise none. All right, again, maybe not the best hack, but let me see if here's what I'll no. Let's see. Another annoying thing about this setup is that it's hard to debug because it's running through this like asynchronous wrapper. All right, I will just move on and we'll deal with this in a second. So let's think about looking ahead. So the way we want to do this is we want to consider now all the possible moves from the current position. So let's just say best move. Wait, nope, I don't want that. We're gonna copy this kind of stuff here. I really want to reduce the code repetition here, but I don't think I'm going to do that for now. All right, so moves is going to be legal moves. So what we're going to do is we're going to try to find the best move from the current position that we're considering. And it'll be a different player's turn now, so will that mess things up? Let's see. So U board is now used twice, so let me actually do some renaming here. So this is going to be board. This is going to be board. This is board. And this is board. And then new board is going to be all the candidate boards. And we're going to push the moves, and we're going to do score function. So we're going to call. So this is where we do a recursive call. So this is going to be the interesting call. And then we remember the best one, and then I guess then we return. There's a little bit of weird stuff going to happen here. The best score, I think we return the negation of the best score. And the reason for that is we're going to be considering the best score for our opponent. And I might be missing there might be a sign error in my reasoning. So let's try it out and see what happens. But what we're going to call is this function itself, which is called minimax score. any max score. We're going to call it with new board. We're going to call it with turn, but not turn. So we're going to call it with not turn. So the other player's turn. We're going to call it with current depth +1. So we're going to move to the next depth. And I'll just say max depth. So it's going to continue using the same max depth, and we're going to increment the depth for the next level call. And what this does is, you know, if it's whites, or I guess what in this bot or in this game here, can you not see my cursor? Oh, I didn't know the streaming software doesn't show the cursor. Okay, so in the current chess game, which may or may not allow us to continue, BirdBot is playing as white. So it's white's turn initially, and then it's going to try to figure out what would black do, like what is black's move. So that's why it's not turn, and then it goes on to the next depth. And this not turn construction is a hack, knowing that Python chess implements turn as a Boolean function, Boolean value. In general, it would be better if we figure out like a more portable way to do this, but for now, this is fine. I'll figure out the correct way to do it later. What else is missing here? I think this sort of feels like it might work, but usually what happens is this is going to blow up. But let me see if it works. Let's just try it. So I have to, the question I have is, does it actually, let me see, let me try, you know, one thing that would be useful is if I could tell if it was really doing something different. So if I print something, let's just print some stuff. I don't know what the text representation of the move is, but we'll see. So it would be best move, and that should print stuff out for us. I just don't know if this console wrapper is going to suppress the output. Okay, so if I try this, will that call it? Okay, it made a move, but it didn't output anything. Did not make a good move, so it's probably a sign this isn't working. If it's doing a 3-step look ahead, it would have known that trade, well, the trade is okay, probably, you would think it would be okay, whatever. Let's see if we have any hints about whether it's changed its behavior at all. Oh no, max depth is 0. It shouldn't have changed its behavior. All right, so let's cancel that out, and then let's go to max depth 3 and see if it actually runs. So this part didn't crash. What's a move that will test this? I don't really see one. All right, I'll just try to do some random moves, and BirdBot is offline. So I think we need to, it's like not aware of a game unless it's actively like recently challenged. So I think I'm just going to forfeit this game and try to rematch. Okay, it accepted the rematch, but Lichess didn't send me there. All right, quickly play a move. Okay, now it's doing all this stuff. Is it an infinite? Did I create an infinite loop? I think I created an infinite loop because I don't think 3 moves ahead would. Well, it could be big. Well, let's see. What's the branching factor here? There's at least 8 pawns. I mean, there's 8 pawns, and then basically every piece has at least one. Well, that's not true. You can't move the rooks. Okay. Well, in either case, 3 moves deep could be quite large, but this is a computer. I thought it would be able to handle that. All right, so it's probably a bug. So just to test this out, let's try. If I did 1, then it would look ahead 1 move. I guess my max depth definition is not great, because I think 1 means the way it's defined, 1 will look at the next move. So let's see if that works. Okay, it actually finished computing. But that's not a good move. So how do we know if it's working? Okay, I just made some bad moves. All right, what is the right test here? They keep saying I should play G5, H7. Which is a free pawn, I suppose. H7, F8. Trade. I mean, it's computing the opponent's my best move based just on material count. So it's possible this is working, and it's possible that depth 3 was just too big to compute, maybe especially with me printing out all the moves. So actually what I will do, I want to do something, let's say, one way to do this, so one thing I'm not doing is I'm not checking for like repeat positions, but let's just keep track. Whoops. Let's just keep track of how many pieces we've we'll keep track of how many moves we've considered. And I'm going to, rather than print this, I'm going to say this is going to happen only in the how am I going to do this? Current depth, returns material count. You know what? This is going to be harder to do than I want to do right now. So never mind. All right. So what's a good way for me to keep track of this? I mean, I can just try it. Let's try a depth 2 and see if it's actually working. I mean, logically, it looks like it's correct, right? So it's calculating the best move for the current position, and then returning the score of that move, for the opponent, and it's calculating the best move based on the minimax score, which then will recurse down from the next board position. I mean, one possibility is I could have messed this up. Like, this would be a bad thing if I was playing like the worst move. That would be funny. If I flipped this by accident, then I could be playing the worst move. I don't think that's what it's doing. All right, so let's see if we go to max depth 2, if we get any interesting behavior. Am I still printing this? Oh, shoot. All right, that's going to really slow things down. Just out of curiosity, yeah, okay. I had to restart the process to get rid of anything like that. Let's restart the process. All right, so how do we test something? Let's get it to an end game. That's no, that's then it really needs to look ahead a lot of moves. That's too many moves to look ahead. Okay, so now it's doing some weird king moves. Sorry, I'm not actually paying attention to the chess here. I'm just moving randomly. I don't actually know how to test this AI in this position. What do you think? How do you design a test for someone, though, if you want to see if they can look ahead more than 2 moves? I mean, for one thing, the AI before was like hanging pieces just to grab you know, it would like try to grab a free pawn, but it wasn't free. It shouldn't do that if it's looking ahead 3 moves. So let me start over and see if it, let's start a new game and see if it, well, actually, let's see. So, I mean, this is a free pawn. It's not taking it. I mean, not free, sorry. It looks like a free pawn to an AI that can't look ahead. They can get free material, you know. Okay, so here's the test, right? So right now, if I make a random move, if the rook takes this pawn, then it's like just look, you know, then it's just trying to improve material count without thinking that, oh, well, then it will lose the rook. So let's try that. Did it crash? Nope. Okay, it was just thinking really hard. Yeah, so at some point we'll have to work on scaling this up better, because right now this is the most naive algorithm. So now, if, on the other hand, if I hang my pawn, if I push it, that looking at 3 moves, it might be no, probably then the rook can escape. So this should be a free pawn. It should take it. Let's see if it takes it. Nope. Okay, I think I just did something wrong. It's not working. So what is how do we know what's wrong? Will it take my queen? Okay, at least it did that. So why wouldn't it take that pawn? Is there some trick I'm not seeing? Okay, fine. Now it has reinforcement. Can it take the pawn now? Okay, that's interesting. That's interesting. I wonder why it did that. Okay, so let's think through this code. So it's only going depth 2, so that means, so the first time it's just looking at the in fact, this, oh, interesting. So the way that I programmed this, it looks at all the possible next positions. So depth 0 is actually a depth 1 in most people's counting, right? It's like you're looking at the next move. So you look at the outcome of the move, you decide the material count. That's the basic version. But now we're going ahead 2 more steps. So now we're also considering, you know, after we make our move, what does the opponent do? And then after the opponent makes the move, what do we do? Maybe one more. I think one more the way I programmed it. So that I can see how that I can see why that's slow. But then why? I want to try. I wonder if I can continue from a position. Well, anyway, let me just make some random moves. Oh, this is gonna be so slow. I feel like depth 2 is too much. So I just lost. Okay. Great. Well, that's good, I guess. But that was just a 1 move look ahead. I hung checkmate. So that wasn't looking ahead at all. Okay. Let's see. How else do we test this? So it's just what is it doing? I don't know why. Okay, it's not making any sense. Okay, interesting. But I guess one of the, it's hard to coerce the computer into a certain position. I have to figure out how to do that in Lichess. Can I challenge the bot to starting from a certain position? So if I go to an analysis board and I'll just make something happen, what I'm thinking is, in these situations where you have to count pieces of who's attacking whom, like, I don't want to do Skemden even, that might be where, like, I wonder what it would do here, because, you know, this is that tricky thing where it looks like there's a, you know, white can take a pawn, then black takes a pawn, and then you have this, like, this stuff. Or like Stafford Gambit stuff, but that's really tricky. I don't think I want to give my 3-step look ahead bot tricky gambits to deal with right now. I don't know how do I test this. I mean, it seems to, like, the code seems to do what I want. I don't know. How do I know if it's going the other way? Okay, let's just, as a sanity check, let's try this and see if it does something really stupid. If you know, if this should be expecting the opponent to play the worst move, which is kind of like how some beginners play. It's like, you know, what happens if you pretend you can have 2 moves in a row, and what do? Okay, so what am I doing? I'm looking ahead 2, and I think I'm having it set up to play as if the opponent will play as stupidly as possible. Whoa, wait, what just happened? It jumped to a different game. Oh, this game's still going. I didn't cancel it. Oh, I'll just forfeit this. Okay, sorry, this is the game I just started. Let's see. So, are you going to move the knight? Okay, that wasn't necessarily a look ahead. I don't love the move I just made, but it's fine. Okay. Okay. Well, it seems like it's doing worse. What? What is... This is how you you know, if you need to, like, play against someone who's lower rated than you, you can move your knight back and forth to, like, give them a head start. Is that what this bot's gonna keep doing? I don't know. Okay, so so is it going to protect this? Because that's kind of a look at, yeah, okay, that kind of, that could have been real. I don't know. Wait, no, it's not. That's terrible. That's a terrible move. Okay, so I'm not sure. I mean, this looks like it's making random terrible moves. It's assuming I'm not going to take the queen. Okay, so if I believe that this is flipping things the wrong way, then what I've done is I've assumed that when it looks ahead, it's going to guess that the opponent will play the worst possible move it could play. Wait, is that actually a good move? No, right? Oh, wait. Wait, hold on. Did it actually find a good move? So I thought I won the queen, but I did not, because now it's threatening my queen. If I take, then it takes, right? I mean, it's not terrible. It's okay. It's, will it take my queen? Probably with check. So then I mean, that's really good, but it's better than. Okay, I thought it was totally stupid, but it's not that. It's not totally stupid. So is it possible I did write turn incorrectly? It was this turn supposed to be minimax score turn. I don't know. It doesn't make sense. I think it has to be not turn. So I think that. But then how is it playing okay-ish moves? Is it just? Am I just seeing patterns where there are none? Because that move was not good. It's moving this knight back and forth again. Okay. My logic says it should be not turn. It should be looking at. Oh wait. Should this be not turn? Have I been messing it completely up? Let's say what happens. No wait. So we already tried this. This should be turn. Oh, because turn is the other. I think it's still correct. This is confusing. There's always off by one potential errors. Okay. I do have actual work to do, so I probably should stop soon. So I've been doing this for 55 minutes. I'll do 5 more minutes of trying to hack on this and debug it, and then I will stop. What? Okay, so what else can we do to test this? Like, what's the sanity, or what is the guarantee? What will guarantee that this is actually working correctly? So I believe it should be okay. So the first thing I did before, which was test just the material count. So let's go back to that just to try things out, and then maybe I'll go to depth 1 and see if that changes any behavior. And let's think about what will we see at depth 1. So at depth 1 we should see, like, we shouldn't see the computer take a piece that is that's defended, right? Like, it won't like use a queen to take a pawn. So I can try to induce that from how do I do that? I guess I can. It keeps moving the knight here, so if I push a pawn here, see if it moves the knight over and thinks it can capture a free pawn. Is it thinking, or is it not connecting? Doesn't look like it's connecting. Alright, I'm going to forfeit this game. This is very clunky. And, okay, accepted that game. So now I have to find it. Here we go. And let's try to see if it will take, okay, so I'm going to, so this square is defended, this square is defended. So let's move pawn there. Yeah, I took it. Okay, so that's right. It increased its material advantage, but without realizing that on the next move I can just take it back. So now if I set to depth 1, what we should see is it won't do that. So let's give it a let's just continue from here. I guess, what's a good way to continue from here? I mean, it might think you can take this piece. I mean, it might think you can take this piece on the next turn. So I'll just move someplace random, see what it does. Depth 1 didn't do the right thing. Why not? Did I actually rerun this? I didn't rerun it. Okay. It's because I didn't actually change the program running. I just changed the text on the screen. All right. So now that it's running, I'm going to. I mean, a fair trade is okay, so probably that's not a good test. I'll just make some random moves and analyze what the computer does, or it won't work. Yeah. Okay. Yeah. Okay. Knight out. So if I push this pawn, it will be hanging, and it should take it. So that's not a great test. So let's defend that pawn. I'll go like this. Oh, all right. I'll just do the random move. I think here's a question: Will the computer take this pawn now that it's looking ahead once? It didn't. That's good. Maybe it's actually working. So the converse, or the test the other way is to see if it will take truly free material, which I guess I can't set that up easily here. So I'll threaten the knight and make it move away, which is good. Okay, did that. And now where can I don't know. Let's just push that and see what happens. All right, so now it's moving its knight around. I wonder why it would do that. If it's looking ahead twice, there's no move that would lead to any material advantage looking ahead twice. I think that the openings are really difficult for these types of pure look ahead computers. That's why I think that was one of the challenges in early chess engines, because you know, with good play, like nothing happens in the opening. I mean, nothing happens in terms of material count. If the opponent is only trying to get material. So at some point then we might need to include some of that other stuff like space or king safety or something. How else do I test this? Oh, okay, so free. Let's give it a truly. No, that's not free. Oh, here's another test. So if I push this pawn, it looks, you know, to an engine that can't look ahead, it looks like it's available, but it's defended. So let's see. Yeah, it doesn't take it. Okay, I guess that's good. Maybe this is actually working. You know, like I said, I have to stop now. But maybe this is working. So all I did was add this like recursive call look ahead. It's not very advanced. I wonder if this would work well in like a really simple end game with only a small number of pieces on the board. Then we could probably look ahead further. But right now we can't do that because it's too expensive. Well, okay. Anyway, so I'm going to stop the stream now. So yeah, so today what we did was I think we built a working Minimax AI, and it's just not very good because Minimax by itself at the, you know, without any tricks to reduce the search costs, can't look very deep. And when it, you know, if it only looks 2 steps ahead, it's not able to make good moves in the opening, perhaps not anywhere in the game. So it really needs good depth to make real progress. But I think it's working. So now I guess next time maybe it's try to make this faster by pruning the search space, or maybe I don't know what the next plan would be. There's a few things we can try. Pruning is probably one way to go, so that we can try to look deeper. We could also do the thing that AlphaGo and AlphaZero do, which is randomized. They do some randomized search. We could do something like that. I don't know. I'll think about it. Okay. All right. I'll end the stream now. So hopefully that was interesting. And this bot only runs when I turn it on my laptop or my desktop computer, so it's not available for you to play. At some point, maybe I'll put it on a server and then people can play it. But for now, it only runs when I'm online actually trying this. Okay. End stream.